so we're going to start with number 8, since I was asked by 3 separate people about this football being kicked to ground level. With this, how long is the football in air before it hits the ground? So what I would start, first thing I would start with your Y with is that the football is a projectile. Therefore, guys, remember, if you don't need this one, you can work on your own, but just keep it down low enough so I can hear myself. All right? So the vertical acceleration is 9.80 meters per second squared down. And the horizontal acceleration is 0. I mean, it's those 2 factors that make it a projectile. So that's going to be true of all projectiles. Now what I would look at is I'd look at the problem a little more carefully and notice that its initial velocity has both a vertical, is both vertical and horizontal. And I would notice, I need to see your points now. And I'd notice that it lands, it's kicked from the ground and lands on the ground. Okay? So those are 2 things that I would note in my Y. Initial velocity, both vertical and horizontal, and lands on ground and starts on ground. So those are, I mean, the projectile effect is the general overall idea here. Those 2 others are specific to this problem. Those 3 dots are from mountain there. All right, so now the first thing I'm going to do in my, I'm going to draw myself a little picture just to better situate my mind around it. I've got the ground. My football follows the path like that. Now, because it's moving in 2 dimensions and it's curved, that's how I know that it's accelerating. Right? If it was a straight line, I know it wasn't accelerating. But a curved line tells me, hey, there's some acceleration going on here. And because it's a projectile, it's all in the vertical. Let's see, what else do they tell me? Ground level, lands at ground level. And they want to know how long it is in the air. So, if I take a tiny little snapshot of right here and blow that up into a bigger picture, that initial velocity is in that direction. Tells me 24.0 meters per second. And it says it's at an angle of 58.5 above the horizontal. So that angle is 58.5 degrees. And that's the initial velocity right at that beginning point. Does it continue in that straight line? No, because it's accelerating, it's curving. Let's see. What height do you want to call the ground at? 0. Okay, so the height of the ground is at 0 meters. This position, we'll also call it 0 meters horizontally. Okay with that? All right. So I want to be able to separate the horizontal and the vertical because I know that they share the time, but nothing else in common. So the one thing I have that's in both of them is this velocity. So I need to take that velocity that I drew in my little diagram up here and break it into what's it doing, what's its horizontal component and what's its vertical component. I know the hypotenuse of this triangle now is 24 meters per second. This interior angle is 58.5 degrees. So that makes the adjacent side to that angle, and adjacent, remember, is always related to cosine, makes the adjacent side 24.0 meters per second, cosine 58.5 degrees. And it makes the opposite side, which is related to sine, 24.0 meters per second, sine 58.5 degrees. So I can forget about the 24 and focus in on the two components so that they're separate. Remember, this is just to make my math easier, because it's easier to do all the math that's in a line. Which one do you think, looking at our diagram, which one is more controlling of the time? The fact that it's got to leave the ground and come back to the ground, or the fact that it starts horizontally, so that's the vertical, or horizontally, that it starts here and it moves out some distance? It's asking for the amount of time. So I just kind of want to think about which one's more restrictive. I would say the vertical is my best guess. Now remember, this is just a guess. So I might even put that up here in my y, that the vertical restricts time. May or may not have that up in my y, but if I realize it, great. So I'm going to start on the, oops, should be using green, on the vertical side. And then if I need it, I'll go on to the horizontal side. So, start over here, let's see. Vertically, I know my D naught is 0 meters. I know I end up back at 0 meters. My B initial is 24.0 meters per second, sine 58.5 degrees. Now, if that makes you really nervous, having that as, and you look at that and you go, that's not a number. Well, it actually is. And if we do it out on the calculator, it's just the number 20.463336394 meters per second. Does that number make you more comfortable than the one with the trig function in it? Some people it does, some people it doesn't matter. And then I know, let's see, I know my D final, or do I? I know my acceleration. That's, should we call down negative? Is that okay? Call down negative 9.80 meters per second squared. Do I know my final velocity? Okay, I might. Well, no, that can never come on my vertical side because it's horizontal.
Okay.
It lands at the same height that it took off at. No, 0 would mean it stopped. Let's see. Let's try it. Tell me if this stops. You ready to catch? Okay. Tell me if this stops just before it hits your hand. No, it was still moving, right? I agree. Um, but let's see. It goes up. What does it do at the very top vertically? Stops and then comes back down. Which takes more time, going up or coming down? Same. Same exact amount of time, right? So if it went up and it went from 20 point blah, 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 to 0, and then it starts at 0 and it comes back down for the same amount of time, what speed is it going to get up to? Yeah, 20 point, but negative, right? Because it'll be downwards. So that could be helpful. So I'm going to put in here negative 20.4633639.4 meters per second. If you realize that, great. If you don't, fine. You can also do it without realizing that. Huh? Through that logic that we were just going through, that if it takes a certain amount of time to go up, and it takes the same amount of time to come back down. Okay, good. Okay. But so I'm going to star this, because if you realize that, I'm going to make this. If you realize that fact, so if you realize that fact, the starred solution is the way you could do it, which says that V final, I'm going to use V final equals V initial plus AT. And my V final is negative 20.46336 blah, 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 meters per second equals my V initial, which I put down as 20.46336 meters per second, plus negative 9.80 meters per second squared, T. Now, if I didn't realize that fact, all right, let's say that you just couldn't pull that fact out of your brain. That's fine. I could use D equals D naught plus V initial T plus 1/2 AT squared. I land at 0 meters. I started at 0 meters. My initial velocity, 20.46336 meters per second times T plus 1/2 negative 9.80 meters per second squared T squared. Looks complicated, right? Because you got extra T's. What if I divided every term by T? What's 0 divided by T? 0. 0 divided by T? And this whole thing divided by T? The T disappears, right? Yeah. So, and here, one of the squared does. So I divide everything by T, I get 0 meters equals 20.46336 meters per second. This is, yeah, minus 1/2 9.80 meters per second squared T. If I do either of these out, I'm going to get the same exact answer, which will be, listening? Okay, let's go back to my premise, was that if you realize this fact, great, continue on this way. If you didn't realize that fact, you could go this way. It's either or. And I get the same answer, which I hope is right. After all, it is Monday. You never know. That's right. Yay. So yeah, if you realize that it can be, and this V final here is only true because it lands at the same height. If it doesn't land at the same height, then you have to go this left-hand method? Yes. Yep. All right, so number 5. The baseball pitcher throws the ball horizontally with this speed. Ooh. Right away, the ball is a projectile. The catcher is this far away from the pitcher. Do you think that's a horizontal or vertical measurement? That distance away. Horizontal. Horizontal, right. And the ball drops and moves the pitcher catcher because it's a projectile, and they want to know how far it drops. So in my, number 5, in my Y, I would start with the ball is a projectile. A lot of them for this section, of course. Therefore, the vertical cell is 9.80 inches squared down, and the horizontal cell is 0. I would probably note here also, when in my thinking about the problem, it starts with only horizontal horizontal velocities. Starts with only horizontal velocity. Vertically, how does its landing point compare to its starting point? It's lower, right? So vertically lands below start. You could even say starting. So it's going to land below its starting point vertically. Horizontally, it's starting off the horizontal velocity. So if I was to draw the path, what it would look like for the path of this, and our ground here, and our pitcher releases it, then it's going to come down to our catcher's mitt down here. Right? It's going to follow this curved path. Its initial velocity is all horizontal, though. Let's see, what else do they tell me? They tell me that that is 37.2 meters a second, and that my catcher is 18.6 meters away. So for me, this is 18.6 meters. So, which direction you guys want to call our positive directions? Up and to the right? Okay, we'll call those positive. What do you want to call this point that the ball is released at? What do you want to call that horizontally? 0 meters horizontally? What about vertically? What do you want to call it? 0 meters? Okay. So that means horizontally, this point where it lands will be at 18.6 meters, and vertically, it will be at negative h. No, because we called where it started 0, and we know it lands below that. That's why we have to have negative there, right? And I know this whole thing is accelerating downwards, right? So which seems more restrictive to you guys? The horizontal or the vertical? Why the vertical? It's going down? Yep. Okay. Now, and I would say, yeah, I'd say they're both restrictive. And because it has to move out a certain 18.6 meters, and it can only move from this down to whatever horizontally, vertically. Problem is, but which one now? So they both seem restricted. Which one do I know more about now? I know more about the horizontal, so I'm going to think maybe I start on the horizontal side. But I agree that they're both restricted. We could pick restrictiveness either way. So let's start this time on the horizontal side. And I'm going to just think about the things that I know. Horizontal side. I know that V naught for horizontal is 0 meters. It goes out to 18.6 meters. V initial horizontally. Oh, wait a minute. It doesn't accelerate horizontally, so that's just V. Right? Because the acceleration horizontally is 0. What did they tell me that was? 37.2 meters per second. Time, I don't know. Then vertically, let's think about the things that I know. Vertically, I know it starts at 0 meters. It's going to end up at negative h. It's V initial when I start. If I throw it just horizontally, how fast is it moving vertically? Huh? Nope. That 37.2 is horizontal. How much of that is vertical? None. So how fast is it moving vertically? None. 0 meters a second. V final, no clue. But I know my acceleration is negative. We said down was negative meters per second squared. Okay. Let's see if I can, from the horizontal side, if I can find the time. Because what I want to know is that h, and it's over on the vertical side. And I just have a gut feeling I don't know enough over there. So I'm going to try this horizontal side and see if I can find the time that will bring me between the two. And then go over there. I could start the vertical. My guess is I would hit a roadblock. I'd hit a point where I'd h and like time or something that I didn't know that I wanted to know. So my gut is telling me start on the horizontal side. Now horizontally, there's only one equation I can use because it has no acceleration, and that is d naught, d equals d naught plus v initial t plus 1/2 at squared. I don't have any other equation to use. That's always going to be 0. So my d is 18.6 meters. Yes, it is. And you can either cross it out or write in 0 meters like I just did. Either way works. Plus, oh, that's sorry, that should be a plus. Plus my 37.2 meters per second t. Cool. I'm going to be able to find t. Because I have all numbers in one variable. And I do that, 18.6, 37.2. Oh, I got lucky. 0.5 seconds for me. Nice. So that is my time. That is for both. So 0.5 seconds. And then I can use that over here also. No, I mean, I'm going to keep all my sig figs in my calculator, but luckily mine just came out nicely. Okay. And I would keep all my sig figs here, because it doesn't ask me, only when I put in my answer do I limit it to 3. When I'm working, keep all of them. Yes, sir. Yes, I did the algebra, which I used the fact that I had 18.6 equals 37.2 t. I wanted to get t by itself. Since 37.2 is multiplied by t, I divide both sides by t. And and that got me t by itself. I'm going to put up some algebra review that will be optional for you guys, but I think will be helpful. I'll put some optional assignments up in WebAssign because I think algebra review would really help you guys in these manipulations. So over here, let's see what I know. I want to know where it ends up. I know where it starts. I know how. Oh, I'm going to use the same equation. And let's see, negative h, g naught is 0, so I'm just going to cross that out this time. B initial 0, oh, so that whole term goes. Oh, and I'm left with 1/2 times a, which is negative 9.80 meters per second squared, t squared. Cool, one variable, all numbers. The negatives are going to cancel out. I'm going to be left with t, right? Oh, wait a minute, I know t. I don't want t. I know t, don't I? My t is, that's good, because I got scared there for a second. I had two variables in one equation. Now I can figure out h. 0.5 squared times half times 9.8. I get 1.22 meters. But actually I got 1.225 meters is my answer. And since there's nothing trailing the 5, it should leave the 2 alone. Let's check